Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer, here at The Construct. My name is Rodrigo, and today we have one of our students, Ashish, who has completed the course ROS 2 Basics in Python in 5 days. It's one of our courses that we offer, and at the end of this course, there is a real robot project you can complete in order to get a presentation. So that's what we're going to be seeing today from our student Ashish. Hi Ashish, how are you?
Yeah, I'm fine, Rodrigo.
All right. Happy to see you. So whenever you want, you can start sharing your screen and just
Yeah.
showing us what you've done with your project.
Hmm. So, sharing my screen. Yeah, I think.
Yeah, I can see it now.
Yeah. Okay. So basically, this is a real robot, and we need to make this robot to follow along the wall at particular distance through wall. So in this project, there are three sections mainly. We need to make the robot to follow along the wall with particular distance. This is the one section. And in this section, we'll use topics like command velocity, like a CMD well topic and a scan topic. Using that, we'll just make follow along the wall. So and the second section is about services section. In this section, we'll make robot to find the nearest wall. So whenever you keep our Turtlebot in any point in our simulation wall, it should go to its nearest wall. It should find its nearest wall, basically that. So for that, we need to create our custom services. So this is the custom services uh, which have empty request and bool response. So that is the second section. And coming to third section is action server, actions. So for that, we need to create an action server where we need to give an update of robot, like how much distance it is covering at particular time. And at the end of this project, we need to print the whole list of odometry X, Y, Z, X, Y, and orientation Z value. So this is the whole project. So
Great.
let me just start simulating, and then we can look at the code. So this odom recorder is our action client, so action server. So I'm starting the server.
Oh, all right.
So now I'm starting my main launch file. So I think now you're here. You can see.
Uh-huh.
One second. Sorry.
And if you can leave the terminal as well, we can sort of see both
So
things happening.
yeah, now you can see the robot is finding its nearest wall, so it is turning towards the wall. So once it faces towards the nearest wall, it moves towards the wall, and now it should the right side of the robot should align, like it should face the right side of the robot should face towards the wall. So that part is completed. Now service completed. Now it's going to action. So now basically it's following wall, and here you can see the total distance. Now it is completed as one, as it is coming as feedback from action server.
Getting tight over there with that obstacle. Nice.
Yeah. Now currently it completed 3 meters.
And it'll stop when you mention 5 or something?
Yeah. So one lap consists of above 5 meters. So I gave us 5.5
All right.
because the robot is not moving straight. It's having some deflection. So we
Yeah.
need to calculate all those distance also. So that's why I gave more than 5.
Yeah, of course. If your algorithm could make your robot either go very straight or very curvy, that would be different. All right. Yeah.
So so we got our result. So robot stopped, and we got our whole result like odometry X, Y, and orientation Z values, and that's it. The total distance is 5.5. Yeah.
Great. All right. So I'm going to do a little different, Ashish. So bear with me here. You have completed last week, I believe, instead of ROS2 basics, you did ROS basics. So in order to not be that repetitive, could you please just focus on differences you remember between ROS and ROS2? Like, oh, like this here is different. Let me than writing it
Yeah.
in ROS1. So could you
Yeah.
sort of tell us what you've done with that in mind, sort of like pointing out certain differences that you noticed between ROS1 and ROS2?
Mhm. So let me tell you my experience.
Mm-hmm.
So when I was dealing with, I think, services. So when I creating my service like wall finding behavior.
Yeah.
So let me show that. From that, I can say the whole difference of ROS2 and ROS1. So this is the wall finder Python file. So here, actually, we need to use laser callback and my service callback.
Yes.
This is my
Two
service callback,
callbacks.
and this is the laser callback. So two callbacks I'm dealing with. So basically in ROS1, when we launch any Python file which consists of multiple callbacks, so all callbacks will run simultaneously. But when coming to ROS2, one callback will run at a time. So no two callbacks or no three callbacks will run simultaneously. So that thing I don't know earlier, because in our course structure, if I'm not wrong, services part comes first, and then callbacks and multi-threading comes next. So I haven't seen that, and I have just directly went into services, and then I completed services part. After that, I just tried on my real robot project. So while doing that, I faced many like issue, because I'm not getting the laser data, because already my service callback was called, and it is not out of it, because it will be out of my callback when I'll get some result. Is it? I think, if I'm not wrong. So my callback, this laser callback function is not triggering. So I'm not getting data from this laser callback. And always when I access data of laser data for this my callback function, I'm getting a 0, because this is not running simultaneously.
Mm.
So I have like I have searched something, and then I came to know that there is one other concept which is multi-threading and like executors. So then I realized, okay, the next topic was that. So I again went into that topic, and then I came into one conclusion that we need to use this concept, which is executors, multi-threading executor, and callback groups.
Mm-hmm.
So this is one of the main difference from ROS 1 and 2.
Great. Great. Yes,
Yeah,
precisely. That's what I wanted you
yeah,
to mention. All right.
yeah. So, and another difference is like we can also mention our quality of service for our laser thing, and command velocity thing. So,
Right.
and mm, and coming to this multi-thread executor, so we need to mention the number of threads. So this number of threads depends on number of executors. Sorry, this callbacks. So each thread will take care of one callback. So we have two callbacks. So I have included as two. So both the callbacks can be what these two threads can be deal with both the callbacks simultaneously. So again, one more thing is for these callback groups, we have two types of groups. One is see here, like I have commented it, return callback group, and another is mutually exclusive callback group. So for return callback group, we can create only one group. As here you can see, return group one, and we can use this return group one uh, to multiple callbacks. Like here in this case, I can take in both the callbacks of my service callback and also my laser callback. So it can deal both the callbacks simultaneously. But in case of mutually callback group, if I
Mm-hmm.
take one callback group, it will be only deal with only one callback. Like it can't what we can't access data uh, of multiple callbacks in this particular one group. So that's why
Right.
we need to make another group like this. So mutually exclusive group one and group two, and we need to assign both of them for different callbacks function. So one group we can't give to both callbacks. So this is one another main thing. So yeah.
Mm-hmm. Mm-hmm. And is this the only place where you have to implement something like this? So you
What
have
do you
three
mean?
programs, right? And
Yeah. The same thing I have done to all the programs.
right, because you
So if
need,
you
yeah, of
see
course, yeah, I
if
see
you
that.
see here, if you see wherever we have callbacks, so we need to have this callback groups and executors. That is the main thing.
But what
So that
other
is that is that
callback?
is, that is basic.
I'm
That is
sorry,
basically. Oh, sorry, sir.
I wanted to ask, what other callback are you running in these main wall following .py? You have the scan callback, and is there another one you
Yeah.
have, like a timer?
This this is called scan callback, and one another is timer. This is
Oh, yes.
this timer triggers my main function, which is perform robot movement. It actually functions like making the robot following through in a wall. So this is the logic. So making some particular distance in this range, and the robot will move through the wall, like along the wall. So this function I'll trigger every point 0.05 seconds, so that I can make sure that parallelly I'll get data from the callback laser callback, and parallelly I'll execute these robot movements using this, and it's the same thing. I use the same callback group. Um, yeah, the same stuff repeats here also.
All right. Okay.
And the same thing when we go to odometry, sorry, not odometry, action where we need to deal with odometry. So I need to call my odom callback, which actually deals with odometry data. And one other callback is this execute. Sorry, uh, execute callback is my action server callback. So both the callbacks I need to trigger. So I took in this case I took differently. I took as
Oh.
return callback, and for that I have given as action callback group for this, just as for the naming purpose. And the same group I have given to this as ODOM callback group, just for naming purpose. I have differentiated
Hmm.
both. One is action callback and one is ODOM callback, and just I have just included ODOM for odometry callback group, and this action server callback for this uh, where is that action callback group. Yeah, I've included both. And one more thing here. Hmm, yeah, that's it.
All right.
Yeah, that's it.
That's it. All right. Um, great. Great job, Ashish. Yes, I wanted to basically point out the differences, and you hit it straight on, which is the usage of the of mutually exclusive callback groups and multi-threaded executors when you have more than one callback. And again, this is in
Yeah.
ROS 2. And the reason for
Mm-hmm.
this,
Mm-hmm.
I might bring in something incorrectly here, but basically, the main idea of why this happens in ROS 2 as opposed to not in ROS is because of the libraries that RCL Pi are built on top of,
Yeah,
as
yeah,
opposed to ROS-B,
yeah.
ROS
Mm.
Pi, I guess.
ROS-Pi,
So
ROS-Pi, and ROS. This is client libraries basically.
right, yeah. So they come from the same base in this ROS2, which is based on CMake and C++. This is why another reason,
Yeah, yeah.
I don't know if you noticed, every time you
Mm.
change something in Python, you have to recompile your package in order for those effects
Yeah,
to take change.
yeah.
And that's because
Mm.
the RCL Pi is just a binding library to the C++ like base
Mm.
code. And I think, I mean, I'm not an expert on this, but that is the main reason why. And it's very important for students to recognize this because otherwise, what you said will happen. You know, you're running your laser callback and you're relying on that laser value to update
Mm.
continuously. But since it's blocked by the service callback, then you would have the same
Yeah,
value over and over. So
yeah. The
perfect.
same
Yes.
value. Yes. Mm.
Yes, yes. All right. Well, congratulations, Ashish. That's a really nice project. Same. I'm assuming doing the other one before helped you out greatly. And let me just ask you, in terms of, oh, one comment by the way. You mentioned that you started doing our course and ran into the service unit, and then
Yeah,
you didn't know that you needed to use multi-threaded, and that was the
yeah,
next
yeah,
unit. That is
yeah, yeah.
that is a mistake by our side, and you are the second student that mentions this. So I will take care of switching those. I think just switching the unit numbers would be perfect, so people don't
Yeah,
have this issue because it's obvious. And so yes, thank you for bringing that to our attention. Um,
yeah.
and
Thanks.
in terms of, I'm just curious. Just question of your preference. Now that you've seen both Ross and Ross 2 working in the robot, and I'm assuming you're taking these courses to, learn more about robotics. Which one do you look forward to using more? Is there a preference you have? Let's say you're building something for your robot and you start coding right away. Is that going to be Ross or
Mm.
Ross 2, and why?
See, as of now, I'll talk as a perspective of industry perspective. So no one, like most of the, I'm from India, so most of the industries are not using ROS 2. They are sticking with ROS 1 because no one want to change what is actually working, right? So most of them also don't know ROS 2. They are not aware of ROS 2, and they only know ROS 1, and they are dealing the stuff, and they don't want to change the whole thing.
Interesting.
So learning ROS 2 will be definitely like beneficial for the future purpose because the end of life is coming near. Like I think in 1 year.
Yes,
In one year, I
that
think
was gonna mention. You're gonna have to
ROS 1.
work in Dockers or in very old distributions, or compile ROS from source.
So I I basically prefer ROS 2 because I think ROS 2 has more security security things in compared to ROS 1 in hardware
Yes,
security things. So that one thing will definitely helpful for the industries. So yeah, so ROS 2, I think
it's the
in future,
future.
yeah, it's a future. Yes, a future. I think
I I'm really
ROS 2
interested.
will rule.
Yeah, yeah, I'm happy. I'm really interested in you saying that about India specifically because I know it's a
Mm.
very big robotic. There's a very big robotics
Yeah,
industry there,
yeah,
and
yeah.
I
Mm.
understand what you mean when you say I don't want to change something that is already working.
Actually working. Yeah, yeah. Mm.
Especially, I mean, ROS 2 has a lot of benefits,
Mm.
especially based,
Yeah.
like you said, security and reliability
Mm.
for with the QoS
Reliability.
topics,
Yes,
etc.,
yes,
etc.
yes.
But it brings in additional problems based on the architecture that is built on, which is DDS, which is Data
Oh, okay.
Distribution Service, which is
Yeah.
basically what's underneath the underneath ROS on top of
Mm.
Ubuntu, sort of. How the messages are transported is different in
Yeah.
ROS and ROS 2. And
Mm.
this this adds complications, networking complications once you start applying ROS2 to a real life scenario with wireless communication between robots, et cetera, et cetera. And this might be this is a great pain point for companies that say, I have it in ROS. If I have to switch to ROS2, then I have to solve these problems. So you start looking at this conflict. By the way, just a shameless plug in here. We're going to be introducing a training specifically for this, for DDS in ROS2 and what it means, and what actually is happening with DDS, and why, for example, one of the most famous things that people get frustrated with ROS2 is, why don't the topics show up when I do ROS2 topic list? Or why won't the action come through when I ask for a docking action in ROS2? So we're going to be looking at those. But I'm really glad that you share with us your opinion to add more to the conversation. So thank you very, very much, Ashish, for your presentation. And hopefully we'll see you again soon.
Yeah.
All right. So let me just change my screen here to say bye. So yes, again, everyone that is watching, you can do what Ashish did here to showcase what you've learned in your courses and obtain a certificate from the construct. So I encourage everyone that is taken to our courses to go ahead and try and do the presentation here for the final project. So I invite everyone else to do this. All right. Thank you one more time, Ashish, and everyone else. We'll see you guys next time for our next video, the next presentation, guys. All right. Bye-bye.
Bye.
Cool.